One of the things that we have that's nice with Pythagorean theorem is there are certain things that happen all the time, and they come out nice and pretty. No decimals, kind of like this one right here. Those are called Pythagorean triples. They're very, very useful in construction, especially. For instance, this summer I was laying tile in my bathroom, and I laid out where I was going to start my tile, and I needed to make sure that it was a right angle. So I had these two lines, and I wanted to lay my tile right here in that first corner, but I need to make sure it's square at a right angle. So what I did is I measured 3 inches out and 4 inches out, or 5 because I needed a little bit more, so I did 6 and 8. So I measured 6 inches out, and I measured 8 inches up, and then I measured this diagonal. And if that diagonal was 10, then I knew that that was a right angle because of these Pythagorean triples. If you pull that up, there are so many videos on YouTube that show you how to use Pythagorean triples to check to make sure that your corners are square if you're framing a window or a door or you're building a foundation or something like that. Anything, lots and lots, it's used in trade a lot. Now, the most common families that we use in Pythagorean triples are 3, 4, and 5, or any multiple of that. So 6, 8, 10. 3 times 2, 4 times 2, 5 times 2. So that would also be your 3x, 4x, or 5x. So 9, 12, 15. Those are all multiples of your Pythagorean triples. So we have a 3, 4, 5, a 5, 12, 13 triple, an 8, 15, 17 triple, and a 7, 24, 25. I would say these two right here are the most common of all the ones that we use. And once we get past this unit, we'll be using Pythagorean theorem all year long. But if you look, a lot of times they're triples. They're meant to be a shortcut. So do you have to use them? No. But let me show you where it's helpful. For instance, this problem right here. I have this trapezoid. It has these two right triangle ends on them. It's an isosceles trapezoid because we have our two sides being 13 here and here. Right? And so I want to find x. Well, x is the entire bottom of the trapezoid. Well, I know that if this side is 9, this side from here to here is 9, because that's a rectangle, has those right angles in there. And so I need to find that other piece. Well, you can go through the math, and you can say, well, 5 squared plus x, or we'll call this y, right? 5 squared plus y squared is equal to 13 squared. Or you can go, wait, if that's 5, and the hypotenuse is 13, right? 5 is the hypotenuse, 13 is the hypotenuse, 17, the longest side's the hypotenuse. 5 and 13, if that's 5 and 13, that means this side has to be 12. I don't even have to do Pythagorean theorem. I just know this is 12 and this is 12. I didn't have to do anything. You can, if you get stuck and you don't remember, you can always go back and do Pythagorean theorem. But there is great benefit to knowing those Pythagorean triples. They're really a time saver, especially on PSAT, SAT, ACT, stuff like that. So 12 plus 9 plus 12 is 33. So the length of that side is 33. Number 5, the problem is I want x. The problem is if you look at x, that right triangle doesn't have enough information because I don't have this side. And to use Pythagorean theorem, you have to know 2 of the 3 sides. This big triangle is not a right triangle, so I can't use Pythagorean theorem on it. But I do know that this is, because that's a linear pair, so I know that's a right triangle. So if I look at this one right here, here's what I notice. I notice that one side is 6 and one side is 10. Right? You can carry on and you can do Pythagorean theorem all day. That's fine, no problem. However, I notice that this is a multiple of 5 and this is a multiple of 3. So I just need to make sure they're the same. This is 3 times 2, right? This is 3 times 2. This is 5 times 2. Well, if I know my triples, then I recognize that this is a 3, 4, 5 multiple. That means this is 4 times 2, or 8. So I already know, without having to do a whole lot of math, that that side, that leg of the triangle is 8. Now it's 8, 12, and then whatever this number is. Well, let's check and see if this is a triple. Well, this would be 4 times 2, and this was 3 times 4. So these are not multiples of 3 and 4. They're not multiples of any of the other ones. So this is not a triple. So I could use it here, but I can't use it here. So sometimes you have to use Pythagorean theorem, but sometimes you don't. This would be 8 squared plus 12 squared is equal to x squared. You get that 64 plus 144 is 208, right? Find the biggest perfect square that goes into 208, and you get 16. So the square root of 16, and 16 goes into it 13 times. The square root of 16 times 13, the square root of 16 is 4, and the square root of 13 is a decimal. It doesn't come out pretty, and so it's 4 square root of 13. And so the answer then is 4 square root of 13 if we leave it exact. That's exact. You've got to understand the difference between exact and approximate. 4 times the square root of 13 is 14 point. But see, look at all those decimals, right? As soon as I say 14.4, that is not approximate. I mean, that is not exact. That is approximate because those numbers exist, and as soon as I cut them out, I've made it not, right? This is what I call a NASA number. If they're going to send me to the moon, that's the number I want them to plug into the calculator. If I'm just going to Home Depot and I just need a roundabout, right, I'm going to go with 14.4, even though it was 14.42. I might even round up to 14.5 if I'm going to Home Depot to buy a board, right? But this is approximate. Please know the difference. All right, this last one. Find the perimeter of triangle ABC. So one of the things, notice that this is on a grid, and the nice thing about it being on a grid is we can start to use Pythagorean theorem instead of the distance formula. Well, we need to turn this into a right triangle. This is not. So what I want to do is to find AB, I'm going to use this little pink triangle right here because the hypotenuse of that pink triangle is the side that I'm looking for. AB, so I would go up 5, and it goes over 12. Well, I notice that's a 5, that's a 12. That means there's a Pythagorean triple. So without having to do Pythagorean theorem, I automatically know that AB is 13. Never had to do a Pythagorean triple, or never had to do Pythagorean theorem. It's a triple. Use them when you can. And then I want BC. So if I want BC, I'm going to draw in this right triangle right here so I can see it. BC is my hypotenuse. One leg is 3, one leg is 4. Well, that's 3, that's 4. That means the hypotenuse has to be 5. Let me point out one thing. Be careful here. If this is 5 and this is 3, this is not a 3, 4, 5 triangle. Okay? This 3, 4, 5 doesn't work because the 5 has to be on the hypotenuse. Because this can't be 4. The hypotenuse can't be shorter than one of the legs. So if it's this way, right, if it looks like this and the hypotenuse is not the longest side and it's not a 5, then you can't use the triple. You have to do Pythagorean theorem like you always do. Doesn't always work. Pythagorean theorem doesn't always work. Then this last one, I want AC. AC is the hypotenuse of this right triangle right here. This has a side length of 2 and a base of 16. Double check that. 2, 4, 6, 8, 10, 12, 14, 16. Yes. Now, that's not a triple. There's not anything with a 2 and a 16. So in this case, you do actually have to do Pythagorean theorem. Let me write this down. BC was 5. So then Pythagorean theorem, 2 squared plus 16 squared is equal to, I'll just call it x squared. You can call it c, whatever you want. 4 plus 256 is 260. 260 is equal to x squared. This time we're going to, we'll go ahead and round it so that we can actually get the perimeter and add them together. So the square root of 260 is 16.12. Right, you type that in, square root of 260. Okay, it's all those decimals. I rounded it, so that's approximately 16.12. And add that together, 16.12, you get that the perimeter is equal to 34.1. So these triples are very, very important. Take the time to memorize them. There are more, but at least know these two. Okay, they're extremely important and they're very, very useful. Pythagorean theorem is a squared plus b squared is equal to c squared, where c is the longest side of the hypotenuse.